I'm not sure kung naato ang uban diri last time or naka-join sila in a class pero atong notes is nasad si Engineer Kita Mundo, so I would suggest na you can also buy his. I think it's around less than 300 pesos per complete na siya. Naghimo sa ako ano init mo kayo? Di-on daw ang aircon. Walay. Iba nila? Nga naman. Ilang giayo? Sige lang. Di siguro grabe kayo or we can open the doors na. Sige. So, natin notes. This is my lecture notes na hinahinay ko compile for this subject. Nasin si Engineer Kita Mundo, similar lang siya in terms of content, not exactly the same. So, naay mauban na ako gikuha, gikan sa iyaha, pero naasay daghan ko na adsad, no? So, sa iyaha sad say more complete iyang ma-explanation na ako yung mga parts na wala ko na-discuss na from his notes, no? So, I would suggest na you can, you can also refer to his notes as well. Okay? So, I'm Engineer Kidila, no? I don't know if you naka-under mo sa ko as una. Margawa siguro. CE ko, Masteral, here in San Carlos. And then, nag-practicing ko more than 10 years as a structural engineer. So, daghan naman ko projects, notably, kaning Oak Ridge, kaning PLV, Robin Land. Daghan sad ko sa projects in Manila, nagtukot, factories under sa URC, no? University Robina. I'm still with contact with them kay daghan pa projects. Nasa ko sa projects sa US, particularly Beverly Hills, no? So daghan sa New York, Fordham University, nag-agisad ko design dito. Okay, so member ko sa ACI, AISC, SAT, PICE, no? Sa structural engineering. Then, I'm working with Sir Ramon Kitamundok sa iyang company sa structural engineering as a senior structural designer and engineering manager, no? So, not only I design structures but I also build them. Okay, under me, I have 15 engineers and architects who's working under me. We do estimates and we do a lot of computation, no? So, mo na siya, 10 years. Then of course, gikan ko sa San Carlos, dagan ko hagbong, no? Hagbong ko sa Mariotan, sa physics. I don't know if nakaagi na mo ana. So, depende na, no? Doesn't mean na nakahagbong mo, dili mo ka-succeed ang paningkamp na kita, which is same sa kanina subject, no? This subject is arguably the most difficult in your course. Kaya it involves around a lot of course subjects in nakuha, specifically differential equation, no? So imong mga classmates sa pikas na block, under man mo ni Sir Fernie sa differential equation, so I expect na since nakapasar mo anan niya, maay na kay mo, no? So not only this requires a lot of knowledge in differential equation, this also requires the knowledge in theory of structures, no? 1 and 2, statics, dynamics of rigid bodies, and then strength of materials, no? So combination of everything. So I would advise na pag hinahinay tag-review anapalik, and then of course not the exam. There will only be 2 major exams, which is the midterms and the finals, but we have problem sets. Here's it works, no? So after sa final exam, walay hangyo ay because there are 2 reasons for that. Ang number 1 kay there is a memo coming from the VPAA na daghan mo wala nag-enroll in yung mga classmates, and then the memo stated that don't give students false hope, no? Which is kusog mahangyo, and the reason why I don't like hangyo is inikagradate ninyo hangyo engineers mo. You're not engineers actually. So kusog mahangyo, and in this industry daghan kay problem sa hangyo ay niya, they cannot do competition, no? Kay Igor siya, sige na sir, ato'y panaog, ang bid kay 30 million, ato na i-15 without actually computing, no? Hindi siya pwede. So I'm pretty strict about that because I am dagan ko clients sa luoy jud kaya no. The project cannot succeed without good engineers, and I believe sa atong education nakaagi mo Sir Fernis and Sir Ramon, I believe they give good education kay I was their product as well sa una. So after sa among steel design sa una, nakapasa mi mga 10 out of 90. So uban naghilak, they accepted their fate. Kami kay nalipay ni mas interest sa mong grado. Pero wala ang new idea kay, for example, my classmates were si Stephanie Cañete, Opalin Seno, Imadil Cayano, no? Ako pa nahagbong yun, well, mo na gina siya. So, ang karon kay they change their method of evaluating kay mo lagi takan problem sets and all that, pero ang problem magin ana kay nakabantay sad ko, especially katong during sa pandemic, our online classes wala gid nag-effort no, effort. And when I interviewed a summa cum laude a year ago from San Carlos, I was very devastated kayo no, wala gid kapasar. So kasagaran sa akong team karon kita ka CPU and CITU. I don't accept USC karon, unfortunately, because the quality is really down, and I'm aware of that, and we're trying to fix that no. So that's one standard that I want to lift because I came here and I don't want to see no, medyo lisod. Kay when I interviewed them, maglisod yun, like I cannot understand why no. So mo to siya. We are trying to fix no. So we're trying to fix the standard here. So not only me ang nag-appeal og tudlo, even the partner of Engineer Gitamutok, si Engineer Copauco, is also teaching now. He is also the co-founder of our firm, and then he is teaching project management, construction management, and estimates quantity surveying. So sa amon ni Sir Ramon is nag-focus mi sa structural engineering. Kay we have a duty to do no. So mo to siya, that's one reason. And the second reason is we have to really work hard no. Kay engineers man ta, I think you're already in 4th year. Next sem is your internship no. Internship pa siguro. So internship, well, you will be exposed to the construction industry na amo sa under maybe sa MUA na asat under sa Jerry Maratas or other companies no? And then you will really see the industry sa construction industry or any other industry that you are in. Pero sa construction industry there are a lot of engineers na mura question mark sad kayo no? So there was last year or 2021 to 2022 na aming thesis group na they were really good. I think naka-doubt man siguro to sila sa best thesis during their time no. Nag-simulate man mi ka ng COVID analysis. So using tools no. Nag-program gid sila. They used VBA no sa Excel. So during their internship kay naka-notice gid sila that there's something wrong gid sa industry, especially sa engineers kay they are lacking a lot of tools or a lot of knowledge, and they are sticking to their gut feeling, which is a no-no sa atua. So gut feeling na mo bitaw nagtuon taw instead of materials or atong mga theory, because we're going to use these theories atong work or possibly atong business. So here comes the other engineers. Well, they don't know a lot of things, but they stick to their gut feeling. Though na may merit ang mga gut feeling, pero naging competition that follows up. So that follows no. So sa our projects in international projects and sa maskin sa Manila lang, kada question nagin siya like references, resources to back it up no. So when I deal with clients like URC, when I say something, not money akong references, here's my computation, that is usually sufficient na. So mo to atong training, and I can assure you that our training here is globally competitive if you put hard work, because my co-workers before was from Harvard and also from MSc, kanang isa to, MIT, yes, sorry, it's MIT. Kanisiya, he was a senior, but I corrected his computation regarding sa iyang sheet piling, no? So, kinsa raman ko. I came from a third world country, but I can correct people from a very prestigious schools that is senior to me. So, we put in the hard work. So, mo to siya, no? So, this doesn't mean na I'm trying to push you down, I'm trying to pull you up, because the only time that you can really be good, no, is really we have to do the hard work. Pero of course, ang uban sad kay naturally talented man gyud. So I can understand that, but coming from me, na daghan kog hagbong like 8 ka buo, I can let you see my ismis, daghan gyud kog hagbong, pero push through ra kita ako among batch sad, no. So mo to siya. Don't be discouraged, no. Of course, kay naay uban na scholarship and all that, but if makasulti ka na nakagraduate tag USC, you can really feel na engineer jud mo. You really need to own that that title ba, no? So karon kay unfortunately we are accepting these people pa because makatubag magid sila, no. They have really good tawag ani response to our questions during sa mga technical interviews and stuff, no. So mo to siya. So mo to ang 2 rules. Of course, my notes have a lot of problem sets. So you are also encouraged to really explore, read more books regarding this matter sa kanilang subject. The exam is open notes, open books, open whatever, electronics ba, unsa na lang. Kulang na lang pagdalay mo mama papa, no. O uyab. Kasi ang inyong uyab kito pa ready eh. So it doesn't matter. I don't mind sa akong last sem na exam, midterms and finals, it was open book. Nagdala gid sila stack of books, no, akong students last semester, technically last year, no. So pero ang uban naay usa ka class more than 2.0 ang grade. Ang usa ka class ahagbong sa tanan. So nga naman, no. So usa ka class they really put in the hard work. And then the exam was literally the example. For example, if you are natay tangke na nakabarog, ang exam nakahigda ra, di na kasolve. Mao gyud nahitabo last sem. So pikas class nakasabot man, so nakasolve gyapon sila. Pero of course, if you don't understand the concepts, wala gyud, no? So maybe from my explanation, kulang siya. So you have 3 options or 2 or 3 options. Ang first option is you can read other people's books, like the authors that I am referring to is Mario Paz, Anesia, si Chopra, and si Tenzien. You can read three of these books if you are a visual learner, no? So if dili gani ka kan kay YouTube University gani, you can search our topics sa YouTube, daghan kaayo, no? There are like 3 or 4 YouTubers that cover structural dynamics, and I think their explanation is really good. And it doesn't matter how you solve the problem as long as the solution is actually the answer is actually the same, no. It's similar to differential equations or structural or theory of structures, kay nakay double integration method, nakay conjugate mean method, area moment method, whatever method, but the answer is still the same, no. So it doesn't matter. Okay, so I can still understand that. So, moving forward, no, these are our contents sa pagkakaroon before midterms, no. So, napako additional chapter. I think you already have your notes. Yes, nakita siya.
Maybe open up the windows.
Yeah, we can open the windows, no. So, sige, please open the windows, and open ang doors, no. Ano ba yung room, Ikas? Kung nila sa kaya, i-check na sa Ikas room, na ba aircon, we can transfer if walay class. Hindi kayo, no? So naman good kay, this room was air ventilated. Karon kay, well, sige na lang. Sige, I think okay naman siguro. I think naning air mo sulod, pero nasi sapa. But anyway, okay naman. So, I won't be discussing this one, ang chapter 1. Actually, it's just a read. It's okay. Not a lot of explanation 2 kani magsugot ta diri, and then we will stop at 2.7 because other two classes is kuto brasad sila diri. Kay kani siya 2.8, 2.9, 2.10 and 2.11 is a lot of examples naman. Okay? So karon we will be discussing the what you call that, the derivation of structural dynamics. Okay, so before we proceed, no, naba may question and clarification before we go into the lecture, no. So if makakita taglain na classroom, mas maayo para natay aircon. So if wala gani, dire na lang ta, okay lang. Ako raman siguro magsingot ani kay si Makupindog and speak lang to. Sa Wednesday na to, no? Kinsa ka na mo-check dito sa taas. Room 5, sa to 541, no? Yeah, sa to. See, I can wait. And then if open ka rin siya, dito ta, okay, para bugnaw. Okay. Lisod pa gid ang subject, singot pa kayo. Paita. So, who is here katong gikan sa lain na class Tuesday and Wednesday? Wala, no? Wala mo siguro? Okay, so this is our first na meeting, no? So again, no, midterm and final rank, then we have our SitWorks is on Canvas. If na may Canvas, I don't know if naa ba? Na ba? Na, no? Sige. I'll post the SitWorks online, then you can submit it online sa para the problem set is also the SitWorks. So you have like a lot of time. Okay, usually like SitWorks is like 2 weeks ang submission. Yes.
Sir, question, sir. For midterms and finals, sir, kay problem sets o sir, or na ay mga ka ng question?
Secret, di na ko musumba na. Bitaw, it's problem sets. It's problem sets.
Item sets, sir?
Usually my exam is like 4 items lang, so 25 points per each. And then it's usually 3 hours. So 1 hour per problem siya, kung di kakuha pa, no? So, but we can do it like 4 problems in 1 hour sa okay rasid kayo. So akong differential equation na exam is like 4 problems, but you can nakasolve siya around 20 minutes lang. But I made it 3 hours because maglisod ang uban, so ang uban kay magtanong sa problem, hinuktok. Ang uban sad maana siya, ang uban sad nagtulog na lang, no? So I don't know. Yes.
Ang imong objection, sir, kay if like wrong na ang answer, wrong na sa dapat solution, like no.
In the real world, yes, pero usually maghata mag trial sa to effort points. Usually it's 1 out of 25. So. Line kayo no kay nasa well, you are in 4th year naman ko. Kato sila kay I gave like 10 points out of 25 for effort. Lower years, it's because sige kina-adjust pa man sila kay dahil man kayo ining-abot sa ano to sa practice na ba kay sir okay naman siguro hugdo akong building pero points for effort na tagay gyud ko kwarta or you still pay me and it never happens. It's usually legalities na so naman kay project karon kay I'm dealing with legalities I 3 in fact, no? So, expert witness ko sa 3 projects and it's messy, no? Ang katong duha ka project, usa ka project is during sa not Yolanda, but sa atong recent na Odette, yeah, sa Odette kay na usa ka village as in the whole village yun nawala gid ilahang ato the whole thing, no? And then sa pikas ra gyud naibalay intact tanan, no? So it was found out that unsa to na ay design flaw sa ilang during sa design phase, and then in the construction kay ang contractor well did not do a really good job, so mo to siya man na lang kay Odette or typhoon kay at least ang ato pra nalupad kay kung earthquake to natumbag ito tanan. So nakit ko na kato na same issue naka-store ko sa owner, then yang pinaka-grabe ako na experience or naka-story sa ako ang owner is sa ako nagpalit ko worth 5 million na balay but I cannot stay here because it's not safe. So mo grabe kay na impact sa ako. Okay, you bought a home pa maka-feel kag safe, pero di ka ka-stay sa imong own home, no? So dako kay siya legal charges karon kato na designer. So expert witness man mi ato ni Sir Ramon. I did a lot of simulations and then may nalang gyud Odette na un or typhoon na una kay if earthquake gyud to natumbag gyud ang mga bumbong and columns. So mo to siya.
What was the main reason, sir?
Ha?
What was the main reason?
Ang main reason ato niya kay, diba, once you design your structure, usually sa ato ang training is you design the beam, you design the column, diba, to support its loading. Pero wala ka consider sa designer is the connection, how you connect the beam to the column. So kato man ang weakest point. Kay ang gibuhat sa site kay for example, kabilya ni siya, then nasa ilain kabilya, top view ni siya. Gibuhat sa site ang gisulti ang owner sa unsa to during sa construction kay ang connection niya gikisan ra og weld more siya okay man na. No? Gikisan ra og weld money lang term. So kato siya this is very weak. And then ang mga walls kay very dako man siya so it's very rigid so strong kay ang wall. So ang wall won't fail but your connections will. So meaning ana ni inikatagag sa inika-fail sa connection, the whole is still intact which is very heavy, no? So mo to siya may nalang gid Odette mo to more siya silver lining ba or negative gyapon bitaw pero ano hitabo no. So kani siya it was a mess gyud. More na feature man ganito sa sound sa to kana gabi ka sa Facebook na problem ato. Nasa daghan man legalities karon nasa ko na encounter na na student pag-work siya napasa og board then iyang client kay attorney so nag-design siya in balay two-story with roofing or roof deck pa to. So nahitabo is nagamit siya program STAAD ba it was STAAD na inika-discuss na okay during sa construction inika-buhos after sa buhos kay ni ana man ang beams tanan sub so daghan kay cracking, no? So when we investigated kay mga beams kay very very small jud. So when we asked the structural engineer of record which is our newly graduate ang iyang tubag pirmi is mao man nagawa sa STAAD. Mao man gyud ang design sa STAAD. Diba? So mo to ang result. So what happened is may nalang gyud ang attorney wala nikiha sa newly grad, no? Pero iyahang retrofitting na cost is twice as much as, you know, you just demolish the whole house and then rebuild it. So times 2 iyang gasto, no? So nagtipid siya pero again, iyang costing mas greater. Wala man siya nakakita gid og really good na structural engineer. So sa amo na sa structural engineering magid kay it's best to be mentored first kanang maskin 2 years minimum to really design kay daghan magid siya kanang we think na may nakita sa kadin pero daghan ta na miss out ay kay wala man na discuss tanan connection design. I don't think naka-discuss mo connection design, no? How do we or kung magstorya ko SMRF kasabot ba mo ani, no? So wala gyud diba? So familiar ra siya, no? So dili man ta ka-design pataka because again we are in the seismic zone 4 or seismic region, no? So we have certain code requirement. Specifically in concrete, we need, or concrete and steel, we need to design it as an SMRF or special moment resisting frame that can resist lateral loads, specifically sa seismic, no? Secondary is wind. So kana siya, wala siya gitudluan. So it's actually research and at your own. So mo na ang design. So among design ni Sir Ramon kay we really studied it. So sa undergrad kay you just design the beam, you just design the column, you design the footing, that's it, no? Applicable siya low story, yeah. But you can also go high story as long as you understand these concepts. Okay, Raman, our license does not restrict us from practicing designing 100 story if you like, as long as you can assure that your math is accurate, no, and sakto, and then you have the confidence. So Mo to siya ang problem karon kay di wala mo'y confidence, wala gyud. Sama na siya, no? So, more na side track na ito na. So, 7 o'clock na. So, aside from kato, sa pailain question that you want to ask before we move on, wala tayo sa 50541? Sa to? Wala, no? Well, what time? Wala yung tao. Close that? Wala, yun. So, kadiri na lang kita. Antuso na lang nato. Okay, so, let's start with the chapter 2, no? The analysis of free vibration. So, hopefully, during sa wala tanag storya nakabasa mo ani, but I'll try to unsa to. Let's catch up to the other classes. So, oops, di siya na center to. Ano siya? So this lecture is heavily dependent sa ato ang differential equations. So at kanina subject is actually this is a master subject currently bring down sa CE undergraduate na level. So the difficulty is very high. But what we try to do is we are going to discuss only the basic ones, the basic principles sa dynamics. So kani si dynamics is really good once you design like blast loading, wave loading sa bridge, no? Mga vibration problems, like for example, if na katong sa Ayala, if na nag-ato mo sa cinema, kusog ang vibration, nga naman na siya, so how do you solve that? I think it was Sir Dukay ang nakasolve ato. He was hired by Ayala people, no? Alright, sige. Okay, structure engineers, very small naman. It's a small group of structure engineers. Tuod na daghan kay, pero ang usually mo sa kamay naman. Okay, so dirita sa analysis of free vibration, no? So our structure can be modeled in a very simple na system, which is what we call the spring mass damper na system. This system or this subject matter is under ni siya sa differential equations, no? Hopefully si Sir Furnace naka-discuss na siya spring mass damper na system. If wala ka na, we have to run it through lang. Madili kayo kung mag-dive in very deep how to solve differential equations. Okay, so money siya, no? So what will happen is we want to model our multi-story building or even a single-story building in terms of a spring mass damper. A reason why we want the reason why we chose the spring mass damper na system as our tool to model buildings, it's because it's the most nearest to what can it predict, no? So it can duol gyud siya sa reality sa kanina model. So sa spring mass damper is nasa three components: the mass as spring, which is what you call your stiffness of your structure. Then the damper is what is the familiar ba mo sa damper? Dili, no? Hamper lang. Sige, ang damper is this one, no? Kung natin portahan, kani ang damper. This the damper. So akong buhaton is diba, kung ako i-close ang door, what does this do? It slows down, diba? So meaning ang damper is actually the thing that makes your system slow down to reach equilibrium. So mo na ang trabaho sa damper. Kung walay damper, next na siya, diba? So si structure has an inherent damper. Every structure has an inherent damper because if wala siya damper, if masoy ka ng building, masoy siya forever, no? But it's not the case. So mo na ang naa siya damper, no? And then of course your mass is your structure itself, no? And the easiest to compute of all of those three is actually the mass, diba? The mass is actually the dead load and the live load, diba? So which is easy to compute kay pag-format ka sa volume of the concrete, volume of the steel, no? You convert the volume into weight and then you add those up, that is your mass. Usually the very difficult one is the damper and the stiffness, no? But the stiffness can be computed by your theory of structures and your theory of structures 1 and 2 using area moment method, moment distribution method, slope deflection method, and whatever. So mo to siya, we have to review those, pero I think isa ganito yung professor sa theory of structures. Burden ba to? May na kay mo ana, no? So if magkastorya ko kanang sa to, cantilever na deflection makasolve na mo. Pila may maximum deflection sa cantilever kung nadiri ang load?
5.
5? Sure, 5?
Deflection or?
Oh, deflection man, atong istorya.
No, it's 5 over 368.
Nama,
Itay.
patay. Dili gyud. Or sa imang jud kaya to siya na formula. Katay mo describe kay dili gyud ta cantilever gyud.
What, sir? 8192?
Dili sad layo sad gyapon. So mo na siya, no? So kana na question, it makes you think na okay, I need to review, right? So if you are not confident, you just use double integration method, di ba? Eh mo ni pili ka sa yun. So you relate your AIY double prime is equals to M, di ba? And then you just integrate this twice, you can get the deflection. And then what will happen now is, asa man imuhang maximum deflection, you make your slope theta is equals to 0, or the second, which is your first derivative. You can get the maximum deflection, or you can just say na, I know by maximum deflection is at the tip of my cantilever beam. You can compute the maximum deflection. Okay, so you don't need to memorize. You just need to understand, and hopefully you can recall. So mo to siya, that's why this course is open notes. Kang Sir Ramon dili yun. Pero I require na open notes lang para lesser ang pain, no? Hopefully. Sama na siya. Okay? So, let's go back. So, that's why naka-sidetrack ko gamay because those are the knowledge that you need. Okay? So, let's go back. So, let's try to derive the basic equations of motion of your structural dynamics na system or dynamic na system, no? So again, we study structural dynamics. It's different from structural statics, what we have learned sa theory of structures 1 and 2 and sa strength of materials. It's similar but it's different because our loading now is applied with respect to time. No? So what we have learned sa statics or sa theory of structures 1 and 2, our load is always like kanira, then 10 kilonewton na gyud always, no? Pero sa kanikaron kay ato ang loading is 10 kilonewton sometimes reverse pag yun, no? So that's why it's a hard subject because each time that elapses lahi gyud ang iyang behavior. No? And what we want to know is how can we predict that behavior? If we can predict that behavior, we can have a more valued engineered na design. So dili ra ta dako ra kay column di okay na siya, no? No. Sometimes having too much stiffness is also damaging to your structure because once earthquake hits, you don't want all that earthquake na force to absorb by the building, no? So if mo absorb sa pretend ako ang building, the building would break, diba? It absorbs too much. So what does the building do? It sways. So the swaying motion is actually dissipating of energy, no? And kung absorb siya tanan, wala gyud. Pero if iyang i-absorb, pero iyang i-dissipate through motion, that motion is actually dissipation of energy. So that is why you don't want your building to be super rigid, because if it's super rigid, so you need bigger columns, bigger beams, no? So which in turn makes your structure heavier. If heavy sad siya, the earthquake forces is also heavy, di ba? From our reinforced concrete design and steel design. So sa ganito ang formula sa atong base shear V. Katong sa to, CW times the weight of the structure times something factor divided by I, no? Divided by R. I think naka-discuss mo ana. So, ang problem ani, the base shear is actually directly proportional to the weight. So, the bigger the building, the bigger the earthquake forces. Mao na siya meaning. So, we have to balance. So, do I want a really stiff building or do I want a really slender building? A problem sa slender, if you design it very slender, kung like a 50-story building, No? Kung naka sa top floor, then slender kay siya, basin dili na mo ganahan mo puyo sa building, kay sige siya sway. Maski walay earthquake, walay hangin, mosuy gyapon siya. No? It's because na ang namaki or siya, even though walay hangin pero sa upper area sa imong structure, nagi siya hangin, diba? So masin kato na ordinary hangin, dako man siya na force because you have a big surface area, so makapush yung imong building. So if it's not stiff enough, mo ana gyapon siya yung building. And that leads to a vertical effect. So, more siya, ginikasaka pa lang ka sa elevator, kasukaon na ka, in short. No? So, you have to strike a balance of both. So, moto siya, this is structural dynamics. No? So, if you want to design more better na building, you have to understand this one. So, but we will be discussing sa single story lang, very basic ka dyan, single story lang. No? So, mo na ito. So, that single story is this one, the spring mass damper. No? Kung multi-story building, spring mass damper gyapon, pero siya naka-chuchu train siya, kidaghan na kay siya. No? So let's derive the basic equations of motion, no, of our spring mass damper. So I'll scroll down, and then mo ni siya. This kani siya na explanation. I'll explain it here slowly, no. So how do we derive our differential equation? So, atong storya karon kay puro sa gini differential equation, walay, you don't see numbers, no? You only see letters. So, hopefully you're already comfortable with only letters, no? So, inani siya. So, I will draw the mass yapon. This is the mass. So, this mass is resting on top of a frictionless surface. That is why nakabutang kong liquid, no, to simulate the frictionless surface. And then this mass is being held by two forces. Namely, ang force is, the first one is the damper force or the damping force, no? And the second one is your stiffness of your building or stiffness of this spring, no? Okay? And then this cart or object is subjected to a force that varies with time. So the force P with respect to T. So force that varies in time, no? So, and then I would also put here is this one, no? So this one, kinesia, is our positive direction, no? Positive direction. So x is here. So or the x coordinate, no? So if this mass will move to the right, it's positive na movement. If it moves to the left, it's a negative movement. So based from our static of rigid bodies, how do we get the forces, no, of this system? What should we do? Asa man? Before tayo mag-summation forces, what do we need? Free body diagram, no? So I get ni kalimot. So the structural dynamics is really, or even the design, is really heavily dependent upon your free body diagram. So I would redraw the mass, the object, magbutang ko og kanang forces, diba? So kani siya, I would represent the damper as a damping force, F of C. And then I would represent my spring force as F of S, not K, sorry, F of S. And then, napakoy another missing na force. If you're talking about a dynamic na problem, what do you need to include? Saman, from your dynamics of rigid bodies. EM, I forgot what's ito na EM. Or CE something. What makes a problem a dynamic problem, man? Opposite reaction? Di siguro. Inertia. So, if I'm going to ask you, what's my inertia? What is inertia?
Resistance to change due to rotation.
Rotation? It's a resistance to change. Resistance to change. It can be rotation, it can be displacement, no? So what happens here is the only time the problem becomes dynamic if not the inertial forces. So because we are we are following the Newton's law, second law, no? The summation of forces is equal to mass times acceleration. According to the Limberg na theorem, you can actually make this one as a fictitious force, which is what we call the inertial force, no? Kanisya. So, if I would ask you, nagsige matag-solve, no? Moment of inertia. Ano sa may meaning sa moment of inertia, sir?
Same with inertia, sir, pero with due to the rotation of the object.
Rotation di na. Di siguro. So, if sige matag-solve og moment of inertia, unsa maging moment of inertia, no? Namatay formulas, di ba? But have you actually think na what is really the meaning behind a moment of inertia? So, ato i-break into several terms, no? At least what diri moment of inertia. So, what's the meaning sa inertia? You describe it as the resistance to change. What's may moment? Couple or some sort of like a rotation, no? So, inertia is what then?
Resistance to change due to rotation.
Resistance to change of your body due to the rotational forces, right? So, mo man ang moment of inertia. That is why, once again, ang bending stress formula, my over I, no? So, my I, okay? So, if nakabantay mo, the bending stress is actually related to both the moment and the moment of inertia. Because these are the two factors ni-apply kag moment, ni-apply kag force in terms of a couple, but what is resisting it is actually your moment of inertia. No? That is why it is very important that you solve the moment of inertia kay if ako'y pamutanan ninyo, if this is the beam, nakabarog, and this is the beam, the same beam, nakahigda, which is stronger?
Standing.
Nga naman standing.
Because the formula of inertia is like BH cubed
BH cube niya.
over
Over 12, diba? But
BH.
BH cube over 12 is actually the moment of inertia due to the from the neutral axis, diba? Right? So ang H is cube, no? So that's why it's stronger. Okay, naka-encounter na gid ko, which is very funny. Dito na Talabban na project, nakakita mo ko sa plants. Nay designer, yang gi-design og beams na nakahigda, no? The beam is around 800 mm, so it's almost a meter by 400, right? So, among gi-redesign ato na same building, same framing, ang among design is around 300 by 600 ang beam. So, gamay ka kayo ang difference, right? Kay 400. So, sa among design, during that time, kailangan na kung upat ka 20, no? 20 mm diameter. Sa bottom, guess how much iyang kinahanglan niya?
What's the reverse size, sir?
20 mm. Actually, iyang gi-require is 20 kabuk na 20. The same beam, ha? So, the same loading and the same beam location, the same beam length. It's because wala siya take advantage sa moment of inertia. So, imo ipamagbarog ga, dako kay siya strength. Imo ipahigda, loss of strength, no? So, kana siya, naka-encounter ko like twice, 2 projects na. And it was really weird kung ano iyang higda ang beam, kay wala gyud siya sense in a structural standpoint and even the architectural standpoint. When I asked the architect na ba mo ceiling height requirement, ingon siya kay wala raman. Okay ra gyud ang among ceiling height kay around clear height. For example, from here to the ceiling is, let's say, for example, mga 4 meters siguro ni kataas, right? More or less. So, then, from the ceiling height to the slab on grade or the slab soffit or the bottom of the slab, napa siya like 1 meter na clearance. So, it doesn't make sense na imo i-restrict ang imuhang beam na depth. No? So, which is, moto siya, I don't know what happened to this project. Last year man to, 2023 to na project. I don't know what happened. Pero what I heard is na-kick out ko siya from several companies. Because well, daghan kay mga sepyat, daghan kay mga losses. Well, mo to siya nahita po niya. Kaila pag ko niya personal pag yun, so mo to low jud kay ito siya. Wa ma siya firm understanding of inertia. We take tawag ani, we take the what you call that, the geometry as an advantage to us, no. Okay, so let's go back, no. So we know what is inertia, we know what is the spring force, and we know what is the damper, no. So we can now summation all the forces in the x direction is equals to 0. What will happen is I will add the inertial force, I will add the damping force, I will also add the spring force is equals to my total external force, no, applied to the system. So ang question na to karon kay what is the inertial force? Question mark na. Okay. Sige, I'll rephrase, mahatag og hint, no? So atong physics 31, I think for 31 pagyapon, nag-learn ta regarding sa displacement, nag-learn ta og velocity and acceleration, no? So if so natay tulo ka constant sad, no? So nakay mass, nakay damper na constant, and nakay spring na constant. So kani siya kay connect the dots, no? So tanaw nato which one that connects to which. So if magsulti kag acceleration, asa siya mag-connect, no? Okay? So the acceleration mo ana siya anak. So the acceleration is related to the stiffness. Dili siguro. Okay. So asa siguro yung relationship? Mass. Ngano mass man? Because remember, second law of Newton, di ba? Ani siya? No? Force is equals to mass times acceleration. So, duha na lang. No? And then, sa atong door na example, kay ang velocity is related to the damper because your damper lessens the speed of your structure. So that leads to the displacement is related to your mass, your stiffness, no? So in short, sa atong inertial forces is actually the mass times the acceleration plus the damping force is the velocity times the damping constant, then plus your spring force is actually your stiffness of your structure times the displacement, no? Is equals to P of T. Pero ang kanina problem, kanina equation, na siya problem, it's because we have so many variables at play. We want to relate all these variables into a single variable, right?